Okay, so let's move into the worksheet number 6 from lecture number 6. Okay, so lecture number 6, we discuss about most important two other poses that we did not discuss so far. So one pose is the centripetal pose. So centripetal force is a new kind of force that when there is an object on circular motion, that means we'll say I have object moving on a circle, mass m, right? And radius to the circle is r. So now when this object is moving on a circle, there is a force towards the center, that is we call it as the centripetal force. So now this force actually can be a different force on that situation. In this case, if you attach the object to the cord and if you do the horizontal circular motion, then centripetal force will be your tension force. If you make a turn on the vehicle on the road, when you use the ramps, that also will create the centripetal force. In that case, that can be a friction force. So according to the situation, that centripetal force can be a different force that we have learned so far. But whichever force that has towards the center when there is a circular motion, that force we call it as the centripetal force. So centripetal force will be able to write by using mass of that object and the centripetal acceleration. So now when there is an object moving on this circle, there is a linear speed as we discussed earlier, right? So now that linear speed is related to the acceleration toward the center. This C here, that means both are towards the center. That means you have a force toward the center and there is acceleration toward the center. That is what I call it as AC. Right. So centripetal acceleration will be able to write by using, I'm going to write the acceleration on the bottom by using linear speed divided by the radius, right? Because of that, centripetal force will be mv square over r. Right now, if you know the velocity, if you know the radius, you will be able to calculate the centripetal acceleration, that is AC. If you want to calculate the centripetal force, you can just multiply the acceleration by the mass. That's we call it as the centripetal force. And in addition to that, we discuss about the gravitational force. So gravitational force also very important. That's where that the lowercase g value actually came from when we go to the force of gravity, that g value lowercase g that we talking so far, right? But this is the gravitational force that can apply to the to any two objects. That two objects can be on the earth, it can be planets, or any kind of two objects. If you have two objects, if the mass m, if this one has mass m, the distance between these two centers is r, then there is a force in between these two objects. They are equal and opposite, right? This object has this way, this object has this way, equal and opposite, but magnitude of this force will be able to calculate new constant, mass of one object, mass of next object, and r to the power 2. G is a constant that you can find in the lecture. This is called it as the gravitational, universal gravitational constant, that is the G. That is not lowercase g we discuss, but we combine this lowercase g and uppercase g on the lecture as we discuss, right? We're going to work with those problems on the bottom. So in addition to that, also we discuss the weightlessness, right? So what that means is basically complete Complete absence. Feeling of weight, I would say. Feeling of weight. We call it as the weightlessness, right? That means basically free fall motion. We can call it as the weightlessness because there is no normal force acting on that object. Okay, so I think these are the main concepts that we discuss on this chapter, but we're going to work in this problem and apply the principles that you learn on the lecture part. Okay, now my first question is, the wheel of the car has the radius, this one. So this is the radius, did not change the color anyway, so radius. And then 830 revolution per minute. So that information is important. Balance the machine, determine the period, angular and linear speeds at which the outage of the wheel moving. Okay, so now let's think about the first. R is given. So I need to find the period. So now, how do you find the period in this problem? You need to get the definition of the period first. What is the period is, as we discussed in earlier lecture also. Period is time to complete one cycle. Cycle or revolution. Complete one cycle. Okay, so now if you take the time to complete one cycle, that will be period. If you take how many cycles per second, that is, we call it as the frequency, right? We discussed those things earlier too. So now you need to understand what is given. Always think about the units from the given information. 830 cycles or revolutions per minute. This is what it is given, right? So now let's do this calculation first and see that we know that 1 minute, everybody know this, 1 minute is equal to 60 seconds, right? So let's do this 830 revolution divide by second, but minute I convert into second, that means I have 60 in the denominator, right? So now revolutions per second means what? Revolution per second units. One, that means per second, how many revolution it do? Is that the frequency unit, right? So frequency or F symbol, frequency is basically how many revolutions per second. How many cycles? I'm going to use the cycles per second. We call it as the frequency. Now you see that revolution per second is the units. That means actually this given number divided by 60 is actually your frequency of the problem. So you need to understand that first. So we found the frequency. I'm going to use the symbol. Frequency equal, you see that 830 divided by 60, and that give me around 13.8 hertz. Okay, we found the frequency. That's okay. Frequency is not asking about the period. Anyway, so period is 1 over frequency, as we know. That will be 1 divided by 13.8, and that will be around 0.7 seconds. That's the period is. That's the first question. Okay. Now my next question is find the angular and linear speed. You know that the angular speed is omega, linear speed is v, right? How do you find the omega? So omega is, as we discussed in earlier lecture 2 pi times the frequency. So now you have the answers. 2 pi and frequency is 13.8. This is multiplication. And then you're going to find omega. I'm going to write it by using the pi, right? It is around 27.7 5 in units, radians per second. Okay, radians per second. Okay, my last question is linear speed. Linear speed equal r times omega. That's where I need the given r actually. So now we will be able to calculate r is given 0.29 in SI units and multiplication 27 times 7 and 5. Then you will be able to calculate the velocity that I get around 25 meters per second. 25 meters per second. That's my question number 1. You get an understanding about frequency, period, linear speed, angular speed, those kind of things. Okay. Okay, now let's move into the question number 2. So we have given question and read it, and you have radii of 33 meters. Track contains the turns with radii 33 meters. Find the centripetal acceleration and the centripetal force if the speed 30 meters per second and mass is 100 kilogram. This is mass, this is speed, this is radius. Okay, so now it's very important that you understand what it is asking. Find centripetal acceleration may be a question, or maybe it asking you to calculate centripetal force. Depending on the question, you need to give the answer. Not all things I'm doing here. Only thing I want to see that you see the difference of these things. Okay. Okay, so now it's very simple. First one is centripetal acceleration. We know that how to calculate it. Centripetal acceleration is velocity squared over r. So let's calculate it. That is 34 power 2 divided by 33 meters is around 35 meters per square second. I always concerned about the units. Okay, I'm checking that in your work always. And centripetal force is mass times centripetal acceleration. Then mass is given, that is in SI units. Make sure you use SI unit always, and the acceleration. So now this will give you the centripetal force around 35 and 3 zeros, units of newtons. Okay. Okay, so now let's move into the next question. So the model airplane has the mass, again, make sure that you symbolize this yourself, and moves constant speed on a circle that's parallel to the ground. The path of the airplane of the guideline lie in the same horizontal plane because the weight of the plane is balanced by lift generated by the winds. Find the tension in the 17-meter guideline for the speed of this one. So speed, this one, radius is this one. Okay. After you identify that, the find the tension means basically, in this case, it is the centripetal force, right? So you have, this is, although I draw it in vertical way on the plane, this is a horizontal ground, okay? So your plane is here, plane is projecting in the velocity v, and this is the r is mass of the plane. Then the centripetal force is, as we know, it is mass time acceleration. That will be mass time velocity square over r. You can calculate it, but important thing in here, this centripetal force is the tension force in this case. Okay, that's important concept in here. Okay, so after I find the tension centripetal force, that will be tension force. Okay, now we can calculate this. Centripetal force equal tension force in this case. That will be mass time velocity square over r. Now let's plug in. Mass equal 0.90 times velocity is 19 power 2 divided by the radius is 17. Everything in SI unit. Then you should end up with the newtons. So I got around 19 newtons. Okay, let's move into the question number 4. So in question number 4, I just want you to understand the direction of the velocity. So there is a ping pong ball. So you're going to shoot it from here. When you shoot it, this will go inside the track and it will come out from this end. That is opening end. When it come out from the end, ping pong ball will leave at that point from which path? I have 1 to 5 paths label. Which path will it follow? So it's very important when you make a circular motion, a linear speed will be always tangent. Here it is this way. Here it is tangent this way. Here it is tangent this way. When it come to here, it also in the tangent direction. That is here. So that means only path 2. Always tangential direction. That is the linear speed direction, tangential direction. Okay, so now let's move into the next question. Okay, so now we're going to move into the gravitational force. The force of gravity between two planets depend on what parameters? So you know that the force of gravity between two planets, as we discussed, is depend on this formula, right? So that means if I have one planet here, if I have next planet here, if the distance are, what are the parameters that depend the gravitational force? That's the question is. It's very simple. What parameters? So mass of both planet. Right? And second one is distance between planets. So value G is a constant, it not change, constant value. Okay, so now next part, if the mass of one planet is somehow double, so I can ask double, I can ask 1.5 times, I can ask 3 times. The question you need to read. What will be the force of the gravity between the planet? So when you have mass M and M, you have the force F, right? So now you're going to do one of mass going to be double. It doesn't matter. We'll say this M, I'm going to make it twice of M. When I make it twice of M, force will be twice. Hope that makes sense. Okay. If you double one mass, that will be twice. So now my follow-up question. If you double both mass, these are follow-up questions. Okay, you can review yourself. So my follow-up question, if you double both masses, what will happen to the force? Because you're going to double the M and also you're going to double the M. Then you see that M times M, it will be 4 times of F. Another follow-up question you can see, somehow you're going to double the radius. If you double the distance between planets, what will happen? If you change the R into 2R, you see on the denominator, you have 1 over 4r square. So that means it is 1/4 smaller, 1/4 lower. So you can think yourself this follow-up question. You can double it, you can make it half, you can make it twice, you can do some different coefficients, try with different coefficients on your end. So that is what you're supposed to do to learn the materials better. Okay. And so now let's move into the weightlessness information. So now that I did not allow me to change the color sometime. Then I share the screen. Okay, so now let's move into the next question. Okay, so most of them you already know because I did that elevator problem in your lecture part, but here we have different iterations of the problem. So now my first question is, if you bring a balance to the measure your mass during the ride of the elevator. So when you ride on the elevator, your balance reading that you are getting as the normal force on the balance, that is your weight at that time. Okay, because that means your weight is keep changing when you go up and down on the elevator. Okay, so now my first question is, let's understand that first. If you bring the balance to the elevator, you're going to stand on the elevator, then there is definitely two forces. What are the two forces acting on this object? Everybody know that this is force of gravity. And also there is a normal force. Normal force is the one that we are looking for here. Normal force. Normal force is upward, right? So if you are not riding the elevator, that means you are sitting on the your bathroom scale, then your normal force will be force of gravity. That's why that will give you the weight yourself. So that means in that case, there is no accelerations or anything. Okay, so now let's move into the part A. Okay, it's very important that you definitely draw the free-body diagram with the problem. Otherwise, you don't understand the difference between those things. Okay, if you are planning to going down, what will happen to your weight on the scale? So now your elevator, now we are talking inside the elevator, not outside. This is elevator. So now you still have, I'm not going to draw the person and the balance, you know what I'm talking about. There is a normal force and there is a force of gravity. So now this elevator going downward with some acceleration. Okay, that's the part A. After you see this free body diagram, you know that what is happening, right? So now what is happening, that Newton's second law is net force equal mass time acceleration, right? So now we'll take net force towards y direction. I'm always considering my coordinate as real coordinate system. This is my y direction. I don't have anything on the x direction. Everything I'm writing is for the y direction. Okay. So net force towards y direction is normal force y direction, but Fg is negative y direction because of that Fg. And now I have mass time acceleration also negative direction because of that I have this formula, right? So what I am looking for here is the normal force. Let's write down, solve it for the normal force. So normal force equal negative ma plus Fg. If I rewrite this, ma, Fg, we know it is mass time g, right? So now we have mass, right? I'm going to write mass time g part first and negative m and a. So now this is the normal force you will feel when the elevator going downward. That means what will happen to your weight? Compare with respect to without motion. Without motion, weight is equal mg. Now with motion, when the elevator going down, what will happen is your weight is less because you're going to subtract the MA amount. I hope everybody understands. Weight is less than the normal weight when the elevator going downward. Okay, so now let's go to the part B. Part B, not going to draw the elevator and those things exactly same as you have, but now I have normal force and force of gravity. But now what the elevator do? If you plan to going up, now elevator, let's draw it anyway. So now elevator going upward direction, right? So it's still my y direction is here. I am going to write F net equal Newton's second law, mass time acceleration in y direction. Now I know that I have normal force, Fg down, but now my acceleration part is positive. Now if I go here and you see that normal force equal ma plus mg, right? So now in this formula you can see it is greater than the without motion. Okay, and you can do the same thing for the next two also. Sure that I have enough space in here. Okay, let's move into the C. So now part C, if you plan to stay on the same floor, with what will happen to the weight. So now everybody understand that this is the situation that you are not riding the elevator basically. When you are not riding the elevator, there is no acceleration. When there is no acceleration, as we discussed, your Fn minus Fg, same formula you're going to apply, but no acceleration. Because of that, normal force is exactly equal to mg. The same. Because you are not riding, right? And now last part, D. So D is asking, if your elevator cable break down, what will happen to your weight on the scale during the motion? Can you call this as weightlessness? Okay. So now when the elevator break down, what will happen? So you still have, what do you think what will happen to the normal force if it's breakdown? Okay, so now when it break down, your elevator just going down with the acceleration equal 9.80 g, because it's breakdown, it's pre-fall, right? When that happen, we still have y direction here. What will happen now? You use the again F equal ma, then I have normal force is still upward and force of gravity downward. Now I have negative m, and now acceleration is, I'm going to write a equal g because we don't want to plug the values, mg. Okay. Now when that happen, what will happen to the normal force in this formula? So now normal force will be equal to Fg minus mg. So now normal force equal mg minus mg. That will be, everybody know it is 0. That means there is no normal force when elevator break down, when it moving in free fall motion. So this is free fall. This is what we call it as weightlessness. Okay. So now I show you this all the calculations to get an understanding for you how this elevator problem will work, right? So each step of the problem, but important thing is you need to understand conceptually when the elevator going downward direction with acceleration, your weight is less, you put in less weight onto the your scale, but when the elevator going upward, you put in more weight onto the scale. That's why it is greater. And when there is no acceleration, it's similar to you sitting outside from the elevator. And when the elevator cable break down, what will happen is it is feeling weightlessness. Okay, to get that understanding. Okay, so now let's move into the next couple of questions about the gravitational force, and also I have few concept question from the projectile motion. Okay, Okay, number 7. Determine the speed of Hubble Space Telescope orbiting at the height of 598 kilometers above the Earth's surface. Take the G value. This is the G value that I was using on that formula. And the mass of the Earth is given and the radius of the Earth is given. Right. So now we need to determine the speed of the telescope. Right. So everybody know that we have the satellite orbiting around the Earth, right? What usually happening is you have Earth here, right? So your satellite will be somewhere here. Okay, so if I do it correct scale, you know that the Earth is a big, very, very big radius, right? I cannot even draw compared to the size of the satellite. It's a very big object. So Earth is huge object, right? Okay, so now you have a satellite here. So we need this distance. When this is the satellite, this is the center of the Earth, right? So now between these two objects, we definitely know there is a force. That force will be equal to G times mass of the satellite, mass of the Earth, divided by distance between these two. I'm going to write as R squared. Right. So now when this satellite make a rotation around the Earth, there is a velocity on the satellite in this direction, right? That means actually the force that I write here is centripetal force, that we can write it as mass velocity. This is satellite mass velocity square divided by R. Okay. So now you can see I did not give the mass of the satellite because when I make these two equal to each other, so let's do that in the bottom. So that means GM satellite, M on the Earth over R squared is equal mass of the satellite velocity squared over R. So that divide by mass of satellite, both side will cancel out. Multiply by R will cancel out the R. You're going to do next step yourself. Okay. So now GME divide by R is equal velocity square. So now question is asking velocity. That means I just need mg m Earth divide by R and root of that. And that's the derivation that we need to start. This is your fundamental equation. This is also fundamental equation. Next part is the basically derivation of or understanding of the problem towards the your question. Understand the concept towards the problem. Okay, so now definitely it's very important that this R, you know that the R that I write in here will be equal to this whole distance. This is the radius of the Earth. You need to add the radius of the Earth to the given value. This R will be radius of the Earth plus 598. Let's do that first. 6.38 times 10 to the power 6 plus 598. It is in kilometers. So let's write it. 598 times 10 to the power 3 meters, because I need from meters. 10 to the power 3 meters. Okay. Okay, so I think you guys can plug the values. I'm going to make a little more space in here. And then G is definitely given, mass is given. So this number is closer to, you see that it is, you can add it by using the calculator. Okay. So then it will be easy to get. Your R is around, I get 6.978 times 10 to the power 6 meters. Okay. And then I know that velocity I will be able to calculate by taking root of GM. G is 6.67 times 10 to the negative 11. Since I am using SI unit, I'm not going to write it inside. I know that velocity I will get from meters per second. So now ME, again, I need to give it from kilograms. So that is 5.98 times 10 to the power 24. That's the mass of the Earth. And divide by the R, I just calculated 6.978 times 10 to the power 6. So after you do calculation and make sure that you take the radical value or the square root of that, then you're going to get the value. I have 7.56 times 10 to the power 3 meters per second as velocity. You can always stop and watch the part in there. So I'm going to move into the number 8. Okay, his weight on the earth will be, his weight on the earth will be mass of the astronomer times the G, right? So we have the astronaut somewhere here to put in the weight on here, that will be MA and the G. Okay, so that is the weight, force of gravity basically, right? So that will be equal to, when it do the circular motion, we know that that will be equal to the centripetal force. That means mv square over r. This is also mass of the astronaut, right? So now, since it is asking what is speed, you see that the mass will cancel out, and then speed, I can write it as cross multiply by r, and then we have v equal root of g and r. Okay, so now we can calculate that easily. So plug it to the calculator. 9.80 times r is 1700, and take the root of that, right? So then we will be equal to, I have 130 meters per second. Okay, so according to the question, you need to make sure that you apply the correct concepts, because here we have the astronaut, his weight on the earth, if the radius is 1700 meters. That's not even the earth radius. This is not even the earth. Okay, so this radius is given from what the astronaut made the circle, right? So because of that, need to use the weight equal centripetal force in there. Okay, let's move to question number 9. Okay, this will be basically projectile motion. I know that it's a lot of things for your class doing the projectile motion and things. Because of that, we just simplify it, but I want you to little bit get an understanding when you project the ball, how you're going to use your kinematics to solve the problems. Okay, so we used lot of time, we spend a lot of time by doing the free fall motion and these things. We use that 3 kinematics equation, right? But here, when project the ball, how these 3 kinematics equation work for the that kind of problem, like so projecting the maybe a satellite view, same thing that you did earlier. Maybe you projecting the ball, or maybe you are projecting or firing the bullet from the gun, whatever that we'll call it as the projectile motions. Let's do this simple question, not like very big questions for you guys, but to get an understanding, this is the simplest problem that I can give you. Okay, so there is a airplane, okay, going to project the package. This is with the ground is here, right? So when you project the package with the velocity, it's very important, horizontally project with the constant speed. This is what the velocity is, 115 meters per second. but it is in X direction. That's the important thing. Now plane is going in this way. We don't care about that. But after projecting the package, we are thinking about only the package. We are not thinking about the plane now. And this is how the package land the ground. So now what the question is asking, this height is given. I'm going to write this height is equal 1050 meters, right? Given, and determine the time required to package drop. So time is the one we need to find it out. So it's very important that you understand what is happening in this problem. So one thing is, you see that this package is traveling on this path. That means actually package is not going in X direction, not going in Y direction, but it is moving in both directions. This is X direction, this is Y direction. Okay? When you project it, it will go both direction. Because of that, according to the resultant vector, it will do this projectile motion, right? So now you need to understand you have initial here, final here, right? So now directions informations are important. Let's write down this velocity initial in X direction is the number given, that is 115 meters per second. There is no Y direction velocity. I'm going to write the known things. Initial Y direction, there is no velocity. But X direction initial velocity is 150. You don't have to do those or everything when you do it, but I'm writing it for you to understand. Okay. So now initial height, I'm going to write in here. If I choose this place as 0, 0 point, I have Y initial as 0. But you have Y final, that means how much it drop is here, right? That is negative 1050 meters downward direction, right? And X direction, there is X initial if you want, that is 0. X final, actually we don't know, and even the question does not ask in that for you. Okay. And in addition to that, both of them have the same time. Time is the same for both. But it's very important that there is no acceleration in X direction in projectile motion at all. Any projectile motion, acceleration of X direction is 0. But I'm supposed to write it in here. X direction is 0. No acceleration in X direction. But acceleration in Y direction, always the gravitational acceleration. Y direction, we have always negative 9.80 meters per square second. That is always true. So I distribute X and Y separately, but they have the same time. Okay, so now let's move into the section again. So now what is asking? Time. How do I find the time on the problem? That's the question, right? So now you remember the three equations we discussed. Let me write it in here. I'm going to write it for the Y direction, okay? Y final equal Y initial plus V initial time in Y direction plus half acceleration in Y direction and time is equal. That is one of them. And then V final in Y direction equal V initial in Y direction plus acceleration Y direction time. V final Y squared equal V initial. You don't want these three equations, but I'm going to refresh your mind. Direction Y final minus Y initial. So these are the three equations. We wrote it for Y direction. X direction, you can use the same equation, but X direction, it will be very simplified version of this equation because last two equations are not there. Only equation it will left for the X direction will be X final equal X initial plus V initial X direction time. That's only for X direction. Other all are for Y direction, right? So now by keeping those all the equation in your mind, we need to select the formula that works for the problem. So now problem is asking to find the time. So now according to these four formulas that I have, which one I can use is depend on the given information, depend on what the question is asking. So definitely I need to find the time. Time is the question, right? So that means if there is no time on the equation, I don't want it. So there is no time on this equation. I cannot use it. The second equation, there is no information about the velocity final. And this equation, there is no information about the x initial, x final, and no information about the time. Then only formula left with the first equation, right? So now we're going to rewrite the formula that you choose is working for the problem. After you choose it, rewrite your formula on the equation, and then you're going to make this clear to you according to your information in here. According to the information in here, y initial is 0. According to the information here, this also 0. So now you know that you can calculate the time. Y final equal half ay and time is square. Then time is the one question asking, cross multiply 2y final, and you're going to divide by acceleration. Going to write it the steps yourself. Okay. Okay, but I did it in here. You do not understand. So you have basically a by time is square divided by 2 equal y final, right? So I need to find it for the time. So time, first I multiply both sides by 2, right? And then I divide both sides by a y. So now you see that ay cancel out, 2 cancel out. Because of that, I have t square equal 2 times y final divide by acceleration y. Then take the square root of both sides. Then t equal to y final over acceleration y. Okay, that's what I did in here. So now it's time to plug the values. Root twice y final is a negative value. So that will be 1050. I do not try the negative here because I have a denominator also negative 9.80. That negative and that negative will cancel out. Then you're going to put this into your calculator and then you can find the time. So I have 14.6 seconds. Okay, time I found as 14.6 seconds. Okay, so let's move into question number 10, and we have actually 3 more questions. And the velocity of the typical projectile, this is actually simple understanding of the conceptual things that we discuss about the projectile motion. Okay, let me put into the next one. Okay. Okay, so I have 3 parts in there. The velocity of the typical projectile can be represented by horizontal and vertical components. Okay, so what can you say about it's very important that you understand what the question is asking. I am talking about the velocity. I can ask about the acceleration, right? Velocity, x and y component. When there is a projectile, definitely, as a simple example, my earlier one, I had the velocity in one direction, 0, but we'll say I'm going to project there is a football player going to punt the ball. So when punt the ball, this will go projectile like this, right? So this is the velocity. So now when you project the ball, there is a velocity that projecting, that is the resultant velocity. Now this velocity has the component in x and y direction. This is called it as x direction, this called it as y direction. So now to understand the projectile motion, as I mentioned earlier, this velocity x direction is keeping constant throughout the motion, but y direction velocity is increasing and decreasing independent on here. Since ball going upward direction, velocity is increasing, but at this point velocity going to be 0 in y direction. Then switch the direction and velocity will be downward but increasing. Okay, so that's the conceptual understanding of this projectile motion. So now let's move into this. What can you say about the horizontal component along the path of the projectile? I'm asking about the velocity in here. Okay, horizontal component of the projectile is keep constant. Constant velocity in x direction. Now my next question is, what can you say about the acceleration in horizontal and vertical direction? Give the answer to the question. Don't write down everything on when I ask the question. I need your focus and I need to see you understand difference between these wordings. So next question asking acceleration in horizontal and vertical direction. As I mentioned my earlier question, acceleration in horizontal direction is always 0. That's why velocity is constant. And acceleration in y direction is negative 9.80 meters per second squared. Okay, that's about the acceleration. And what can you say about the velocity in vertical direction? Vertical direction velocity is changing. Vy is changing. That's why you have the acceleration in y direction. That's the conceptual understanding of the projectile. Okay, now let's move into the question number 11. Question number 11, again, a kind of conceptual question that you are going to project the ball 30 up in horizontal ground. That means you have horizontal ground here. You're going to project the ball in 30 degrees. It's with some velocity, right? So now that ball going to be land somewhere here. Now it is asking, as one that is tossed at the same speed at which angle. So it's very important that you go to your lecture part and check those informations. I have a kind of the picture that show you different angle both land in different places. But it's very important that complementary angles land the ball at the same place. So now you need to understand what is the complementary angles means. Complementary angles means add up into 90. 90 degrees, right? That means if you have 30 plus 60 is the 90. If you project with 60 degrees with the same velocity, this ball definitely go up, but it will land at the exactly same place. Okay, that means another which angle? 60 degrees. 60 degrees will land on the same place. Okay, let's move into next question. Also conceptual question, last one actually. From same height and the same time, one ball is dropped, another ball is fired horizontally. Which one will hit the ground first? Explain. So one ball you are in some height, right? One ball you're going to project with velocity this way. One ball going to drop. One ball going to drop on this way. This ball land here, this ball land somewhere here. Number 1 and number 2. Okay, so now question is actually the time. right? And also you probably need to go back and see the lecture part. I clearly mentioned how the time will work, right? So if you drop the ball, this will do the pre-fall motion. If you project the ball, this will do the projectile. This is pre-fall. This is projectile. Okay. So now, although the projectile ball go in the projectile motion, each time interval will say 1/60th second, this ball going to be same height. Then this ball will be same place. This ball will be same place. This ball will be same place. That means both the ball take the same time. Okay. Take the same time. Take the same time. If I need to explain that, how do I explain it? Because your projectile ball and pre-fall ball motion in y direction is the same. Motion of both balls in y direction is the same. That means they should have same time for both balls. Okay, let's stop here.